So in the first one there, we divided out a common 2. That simplifies to 5/4. Now number 2, what do 18 and 24? What's the largest number that the greatest common factor that both of those divide by? 6. So 6 times what is 18? 3. And 6 times what is 24? 4. So if they both divide or multiply by the same number, we can cancel that out. And therefore, when we divide that 6 away, we get 3/4. Okay? So this is what we learned in elementary school, how to simplify a fraction. Now, we got to remember how we added fractions. Okay, so what does it take to add or subtract a fraction? Good. You might write this down. A common denominator. Common denominator. If they have a common denominator, you just add across the top, the numerators. So what is 1/2 plus 3/2? Yeah, you add the tops. That would be 4/2, which obviously that reduces. What's 4 divided by 2? Yeah, so it would be 2. What if they don't have a common denominator? Yeah, we need to multiply the fraction that doesn't match. So what would I need to multiply 3 by so that I get 6? Yeah, so I'm going to multiply this by 2 on top and bottom. And then that gives us 4/6. So we made everything 2 times bigger so that it matches the denominator of the other fraction. And then 4/6 minus 1/6 is how many 6? 3/6, right? And then we always, we go back to the first page, we always simplify that fraction. So what do 3 and 6 both divide by? 3. So obviously we know that that is 1/2. So number 3, they had a common denominator. Number 4, I could multiply one of them so that it matched the other. Number 5, can I multiply 3 to be 5 or 5 to be 3? No. So what's the next smallest number, the least common multiple of 3 and 5? What would the common denominator be? 15. So this is a scenario where we have to multiply both fractions. This one would need to be multiplied by 5 on top on the bottom to get 15. And this one would need to be multiplied by 3 on the top and the bottom to get 15. So we get 12/15 there. Add those together, we get 22/15. Do those numbers divide by the same number? No. So we're going to keep them as improper fractions. So that would be your answer there if it doesn't simplify. And the last review of elementary school, how did we solve a fraction equals a fraction? Yeah, we cross multiply. Now, I'm hoping you don't need to do that on number 6. That should be like the easiest problem you've seen in your entire life. What does x equal? 2, right? 2/3 equals 2/3. So in that case, pretty obvious. But if it's not as obvious, like, can you just look at number 7 and be like, oh, x is blah? No, it's not as obvious. So what I would do here is we cross multiply. So 4 times x is 4x equals, and then we cross multiply the other way. That will give us 21. Divide both sides by 4, and our answer is 21/4. So all of that was basic review. Now we're just going to apply that to a few problems, and that's all we're going to do with our rational functions. We'll be done with rational functions, okay? So number 8, I want to compare to number 1 and 2. So what did we do on 1 and 2 to be able to simplify those numbers? We divided out a common factor, right? So when we get to a polynomial, we need to have factors. So let's first factor this. How does the top factor? What factors of negative 6 add up to 5? Negative 1 plus 6 over what factors of negative 2 add up to positive 1 in the middle there? Negative 1 plus 2. So factor, factor, factor. Now I'm going to kind of rewind again so you can compare these to the easy ones. Here we had 2 times 5, right? And here we had 2 times 4. What did we do with the 2's? We canceled them out, and our answer was what was left over. So same thing on this problem. Is there a factor on top that also occurs on the bottom? Yeah, these x minus 1's cancel out. So your final answer would be x plus 6 over x plus 2. So on... It's true. It also can't equal positive 1. You missed one. But can you do this? I see it all the time. It's not a bad idea. But what's faulty in that thinking? Yeah, remember, by canceling, what are we technically doing? You're dividing that number out. Can you undo adding by just dividing something away? No, so you cannot mix operations there. So that would just be it, okay? Now that you've seen that, give number 9 a go. Simplify everything there that can be simplified. So those two quadratics get factored out. And now comes the fun part. What do we cancel? The 4's cancel. The 5's cancel. So your answer is x minus 4 over x minus 1. Any questions on simplifying rational functions? Factor and cancel. That's all there is to it. Factor, cancel. Factor, cancel. Pretty easy. Okay. Number 10. Adding and subtracting. What do we have to add or subtract fractions? Common denominator. On number 10, are they common? Yes. Yeah. If they're already common, your answer is over that number. And then we just perform our operation across the top. So what is 4x minus 2x minus 8?
2x plus 8.
4x minus, this stuff comes after the minus sign. So what do we have to do? 4x minus both of these things actually means 4x minus 2x plus 8. So be careful of that. You're subtracting both of those things from the first thing. So the way we do that is we distribute the negative through. So it's actually 2x plus 8. Now, sometimes after doing that, something will cancel on the top and the bottom. So does anything cancel here? No, but there is a GCF. It's worth checking. Obviously, they're not, one's plus and one's minus, so nothing's going to cancel. But what could we do to the top now? You could factor out a 2, which would leave behind x plus 4. And then if there happened to be like an x plus 4 on the bottom, at that point we could cancel those out. So it's always something to be aware of. Always double check, kind of think through if anything else is going to cancel. Okay? Now on number 11, let's go ahead and factor these real quick. So this would be x plus 1 times x plus 1. And this one here would be x plus 1 and x minus 1. Now that they're factored, they're easier to compare. Do they match, first and foremost? No. Now, the only thing you can do is multiply more stuff. You can't just take something away suddenly, okay? We can multiply more stuff on the top and the bottom to keep our equations balanced. So what is the left fraction missing that the right fraction has? An x minus 1. So what we need to do is multiply the top and the bottom by the missing factor. Just like we did in elementary school. If the denominators are the same, we multiplied them by something so that they were the same. Now what is the right fraction missing that the left fraction has? Another x plus 1. So I need to multiply this times x plus 1 on the top and the bottom. So now, on the top I have x minus 1 over. Now, we can just keep this factored, but what's a shorter way of writing x plus 1 times x plus 1? Yeah, so if you wanted to, you could call the common denominator x plus 1 squared. Plus, and then on top here, we did 1 times x plus 1, so this is an x plus 1, over the common denominator of x plus 1 times x minus 1. Oh, sorry. The plus 1 is squared. Now that they're common, we add straight across the top. So what is x minus 1 plus x plus 1? 2x. X plus x is 2x. The 1 and the negative 1 cancel out. All over our common denominator of x minus 1 times x plus 1 squared. So get a common denominator, add or subtract across the top. Told you we're going first here, or fast here. The last thing we have to do, number 12 and number 13, how do we solve a fraction equals a fraction? We just did it. What did we do in elementary school? A fraction equals a fraction.
Take out the common factor.
You cross multiply. Thank you. You should be able to solve both these real quick. So cross multiply 12, cross multiply 13, solve for x. See what you get real quick. If you're watching the video, you can pause it for a second and give it a try. What is 4 times x plus 2? Good. Distribute. 4 times 2 things. You have to distribute to the 2 things. So therefore, subtract 4x over, x equals 8. Now, you just have to make sure that when you plug that number back in, there's no zeros in the denominator, just like when we do when we're graphing. So does that work if I plug in the number 8? Yeah, 8 plus 2 on the bottom, that's totally okay. So therefore, that is a good answer. Number 13, we cross multiply. What is 3 times x plus 4? 3x plus 12 equals, what is 2 times x minus 1? 2x minus 2. So I would subtract the 2x over here, that gives me x. Subtract the 12 over here, gives me negative 14. Does that cause any issues when I plug it into the denominators? If I plug in negative 14, does that give me 0 on the bottom? No, so we're good to go there. That's totally okay. All right, last one for today. Solve number 14, cross multiply. So when you cross multiply the first step there, x plus 3 times x plus 7, you got to FOIL that out, would be x squared plus 7x plus 3x plus 21. Cross multiply the other way, 5 times x plus 1 is 15x plus 5. You can combine these, so 7x plus 3x would be 10x. But then, very clearly, this is a quadratic, so we know we're going to want to get it all to one side here. So, subtract the 15x over. And then subtract the 15 over. That gives me 6. What factors of 6 add up to negative 5? So the way we solve the quadratic, factors set the factors equal to 0. So that would be negative 2 and negative 3. Negative times negative is positive 6. Negative 2 plus negative 3 is negative 5. So therefore, what does x equal? 2 and 3. Now, let's go back to the original problem. We said our answers are 2 and 3. When I plug those back into the denominator, Do we have any issues where the denominators are 0? No. So we're good. Those are both correct answers.